So this video is walking you through the worksheet that I posted, one that I would normally do in a classroom situation. So we're trying to find the measurements of angles that I call missing angles. So if you look at this first problem, this is asking you about vertical angles. These two angles, the 133 and the x, are vertical angles. And we know that vertical angles are congruent. So the measure of angle x is 133 degrees. This is a slightly more advanced version of that problem. It doesn't tell you an exact angle measure, but it gives you an expression that is that angle measure. So these two angles, again, are vertical angles, the blue and the green. So in order to find that value for x, it does tell us solve for x, not the measure of the angle. We can set up this equation. Since these angles are vertical, that means that they're congruent. So 9x plus 72 is equal to 4x plus 112. If I continue and solve this, 112 minus 72, I get that x is equal to 8. Now that's one thing that we could ask, but we could also then ask you to plug that back in and find out what the angle measure actually is. So I could plug that into either one of those. Say I plugged it into the blue. I would have 4 times 8, and then I would add the 112, and I'd get that the angle was 144 degrees. If I did that in the green, I would get 9 times 8 is 72, and then if I add 72, I get, oh, surprise, 144 degrees again. I need to get the same answer because those are vertical angles. Just a quick note, though, on what these angles look like. The first angle is clearly obtuse, and it looks like it reasonably could be 133 degrees. The second angle, also clearly obtuse down here, and it looks bigger than the first angle, so it looks like 144 is reasonable. I can't promise you, though, that the angles will always appear to be what they are. So it is not reliable to take these and check them with your protractor. You would have to check them in a different way. As we move on, we're looking at something where we're finding a missing angle for complementary or supplementary angles. When I look at this overall picture, I see that this much of the angle, that right angle symbol there, tells me that that is 90 degrees. Now this entire thing here is 180, so that must mean that this is 180. If this much of it is 90, this much of it on the other side must also be 90, making B and 32 complements. If I just take 90 minus 32, I get that angle B must be equal to 58 degrees. Another type of question that could be asked about this isn't just what angle B is, but maybe I could ask you about the relationship between angle B and that 32-degree angle, and you would say that those two angles are complements or complementary. We see a pair of supplementary angles here. 180 minus that 77 gives you 103, so that's how I came up with x. And although these two angles are not shown quite the same way, these two angles are supplements as well. So I would just have to take 180 minus 128.57 degrees and come up with that 51.43. As we move into the different parallel line angles, we have a lot of different things going on. If I'm just working right here in this area with the 5, 8, and the 7 and the 65, I can use some of the ideas we've already talked about. Across from the 65 is angle 8. Those angles are vertical, so I would make angle 8 65 degrees. If I look 65 and 5 this way, make a linear pair or a pair of supplementary angles. So when I take 180 minus 65, I get 115. That actually works this way too, right? Between angle 8 and angle 5. And I can find angle 7 a whole bunch of different ways. I can either use that supplementary angle idea, or to me the fastest one would just be to say that 7 and 5 are vertical. So 7 is 115. So finding those angles that are all close to the 65, that was pretty easy. How do I make the jump between this set of angles down here and this set of angles up here? Well, we have to assume that these lines are parallel since I've been told these are parallel line angles. But normally we would see some sort of indication, maybe a set of arrows like this. Maybe I'll call this line A and this line B, and I'll tell you that line A is parallel to line B. That tells me that I can use my parallel line ideas. If I know that I can use any one of a number of those ideas to make the jump between this lower set of angles and this upper set of angles. Probably the fastest idea to use, and I'll do it in green because I've changed my angles that I'm working on, would be the idea of corresponding angles. This angle here, which is angle 8, corresponds to this angle here, which is 4. So that must mean that angle 4 is also 65 degrees. I could do corresponding angles across the board and come up with that 115. I could come up with this 65 using corresponding, this 115. There are actually a lot of ways to get the rest of those angles once I've made that jump. But I don't have to use corresponding angles. New idea, so new color. I could have used alternate interior angles. I could say that this angle here, angle 8, is an alternate interior with 2. That must mean that they're congruent. Do you see they make that Z shape? Meaning that angle 2 has to be 65. And then from there, I could jump my way through to 1, 4, and 3. So there are actually a lot of ways I could have done this. I could have used same side interiors, yellow. For example, angle 8 is a same side interior with angle 3. Same side interiors are supplements. So that 65 and that 115 would have to add to 180. Once I got angle 3, that would give me 2, 1, and 4. So there are almost too many ways to find those angles up there, but there are your correct answers. You've got some of those angles are 65 and some are 115. When we start working with polygons like this, it helps to know how many sides my polygon has. So I'm going to count them. I'm going to say there's 1, 2, 3, 4, and 5 sides. I don't know if they're congruent or not. Those almost look like congruent tick marks. That wasn't intended to. It was just intended to help me count sides. That tells me that this is a pentagon. I know with a pentagon, I can find the sum of the interior angles. How do I do that? Well, probably the quickest way is to do n minus 2 times 180. When I do that, I'll take n being 5. This is a pentagon. It's got 5 sides. 5 minus 2 is 3. 3 times 180 gives me 540 degrees. So that means that all of these interior angles must add to 540 degrees. But when I add those angles up, the 68 plus the 121 plus the 103 plus the 85, I get 377. Subtracting 377 from 540 gives me 163, and that's how I got that x equals 163. This is our first real example of a problem that the angles don't look like their measures that are stated on here. This angle to me looks like it's probably about 100 degrees, but the paper says it's 68. I have to go with what the paper says. The angles aren't always shown as they're supposed to be. Probably the author of this particular worksheet, that's me, probably the author of this particular worksheet was unable to find a pentagon that had different angle sizes, and it was just easier to use this pentagon, which is clearly an equal, all the sides are equal here. But we have to go with what's printed on here. So we are going to go with this angle being 68 degrees. So there are actually lots of ways to find different angles and polygons, but this might be the quickest. Finally, we go through a series of questions that we, again, could ask on test questions. They also represent some of the problems that are in your book. Question number 1. I wrote it and I didn't intend it to be as ambiguous as it is, but it's actually very ambiguous, so it gives me an opportunity to talk about a lot of different things. This says, what is the sum of the angles in a 15-gon? So what's wrong with this question? Here's what's wrong. Sum of the angles. It doesn't tell me which angles. Are we talking about interior angles? Are we talking about exterior angles? Are we talking about central angles? 2 of those are pretty easy to answer, because if they're exterior angles, no matter what the polygon, how many sides it has, exterior angles sum to 360 every time. 1 per vertex. Central angles also sum to 360 every single time. Interiors don't. So how do I know what the sum of the interior angles are? That's my n minus 2 times 180 again. This has 15 sides, so I would use 15 minus 2 times 180, or 13 times 180, and I get 2340. And that is why the answer here is 2340. This would be a bad question to ask on a test, though, because it doesn't tell me which angles I'm talking about. So it gave me a great opportunity to talk about what a bad question would be. Let's go ahead and look at question number 2. This says that they have some polygon where the sum of the interior angles is 4320. How many sides does the polygon have? It's asking you to run this equation, the n minus 2 times 180, backwards. So I just have to solve this. So first I'm going to take my 4320 and divide it by my 180. And I get that n minus 2 is equal to 24. That must mean that n is 26. You know that if you don't get a whole number here, then you must have done something wrong, because we know that polygons only have whole number sides. How about question 3? It says, what is the measure of each exterior angle in a regular 16-gon? It's important that this is regular, because regular means that all angles the same, all sides the same measure. Since this is regular, I can just take the sum of the exterior angles and divide it by 16. So when I do take 360 divided by 16, I get 22.5, and that's why I have the answer as 22.5 degrees. If this wasn't regular, I wouldn't be able to do that, and I would have to know some more information about those angles. 4 kind of is like the height, the top tier question. It says that each interior angle in a regular polygon is 156 degrees. How many sides does it have? Well, first of all, it's regular again, so that's good news. I can do that division trick that I used earlier, but I don't know how many sides this has, so I don't know what to divide it by. Let's look at 2 different ways to approach this problem. If each interior angle is 156 degrees, one way to approach this problem is to say that n minus 2 times 180, that's the sum of the interior angles, divided by n, will give me 156. So that's certainly one way to approach it, and you can solve that equation and get the right answer. I think that's a little long, though, and I'd like to show you a trick. There is one other way to do this. If my polygon is over here looking something like this, I can draw an exterior angle that would be attached to my interior angle. How big is that exterior angle? Well, it's 180 minus 156. They're supplements. So that tells me that that exterior angle is 24 degrees. It sure is easier to use the same approach that we used in question 3 here in question 4. If I just say 360 represents the sum of the exteriors, one of them is equal to 24 degrees. 360 divided by 24 gives me 15. That's a lot faster than solving this equation, which, by the way, should also give me 15. If you guys have any questions, feel free to send me an email. I hope that this video was helpful.